Yo, what's good? Let's talk about something that straight up changed the game for humanity: firearms. And nothing revolutionized guns like industrialization did. Before the 1800s rolled around, every single pistol or musket was handcrafted by individual gunsmiths, each one totally unique. But then factories and mass production came through and changed everything. Suddenly, guns would be churned out in crazy numbers. Mix that with major advances in chemistry and metallurgy, and boom, we're looking at a whole new era of warfare. Today we're going to break down how firearms evolved throughout the 19th century, watching handmade muskets transform into mass-produced rifles, and seeing how infantry firepower got concentrated into absolutely terrifying new weapons like the Gatling gun. Chapter 1. The Percussion Cap Revolution and Early Innovations. Alright, so before the 1800s, the only chemical propellant anyone had was black powder, just a simple mix of sulfur, carbon, and potassium nitrate. Now don't get me wrong, black powder was useful on the battlefield, but it was actually a low explosive, burning slower than the speed of sound and spitting out massive amounts of smoke and residue. Plus, you needed a source of ignition to get it burning, which meant every firearm had to have some clunky mechanism like a flintlock to generate a spark. But check this out. At the dawn of the 18th century, this British nobleman named Edward Charles Howard made a discovery that absolutely shook things up: fulminates. These were high explosive compounds that could be detonated just by heat or pressure. Just like that, a whole new world of destructive potential got unlocked, breaking through a technological barrier that had stood for over 600 years. Gunsmiths were quick to see what fulminates could do, which led to percussion cap getting patented in 1822 by this American inventor, Joshua Shaw. This thing was just a simple metal cylinder with a tiny speck of mercury fulminate inside, detonated by getting whacked by a striking mechanism. It created a controlled explosion to ignite the powder charge in a loaded firearm. But European armies? They weren't rushing to adopt it. Even though they ran tons of trials, it wasn't until the 1840s that they really started replacing flintlocks on a large scale. One of the first conflicts that proved the percussion cap musket, or caplock, was legit: the Mexican-American War. U.S. forces started out using Model 1816 smoothbore flintlock muskets, but various armories had already begun mass converting these outdated weapons into caplocks. This American gunsmith Samuel Colt had also patented the first cap-and-ball revolver back in 1836, and became super sought after by any U.S. soldier who could afford one. The most iconic of all was a legendary 1847 Colt Walker single-action revolver, specifically made for Texas Rangers after earlier designs didn't cut it, known as the gun that won the West. The Colt Walker could fire 6.44 caliber bullets before needing a reload, and was considered one of the most powerful handguns in the world until the 1930s. Meanwhile, Mexico had to rely on imports of British Brown Bess flintlock muskets, and didn't have a domestic gun industry needed to upgrade these old weapons to modern standards. Back in Europe, the period of relative peace after the Napoleonic Wars ended suddenly with the Crimean War breaking out in 1853, widely seen as the first truly modern war. By this point, most nations had started issuing caplock muskets as standard infantry weapons, and rifle barrels were becoming commonplace. But soldiers were still exclusively using muzzle-loaded guns, with powder and bullets inserted to the end of the muzzle and pushed down with a ramrod. This put some serious limitations on both accuracy and rate of fire. Lead shot would rattle around inside a smoothbore musket barrel, killing accuracy. Rifle barrels were designed to grip a bullet tight and spin it, but those spiral grooves meant muzzle loading required violently hammering the bullet down with a ramrod. Plenty of potential solutions had been thrown around, but it wasn't until just before the Crimean War that a real breakthrough happened. In 1849, two French army captains named Claude Etienne Minié and Henri Gustave Delvine invented the Minié ball, a cylindrical bullet with etched rings and a conical indentation at its base. When fired, hot gases pushed the thin lead walls of this indentation outward, engaging the rifling and creating a tight seal with the chamber walls. Within 4 years, the French army had adopted the pattern Minié 1851 rifle and licensed the tech to the British, who rolled it out as the P-51 and P-53 Enfields. Even though some older models were still kicking around, the Minié rifles were a powerful force multiplier on Crimean battlefields, being some of the very first guns to successfully combine high accuracy and long range with a high rate of fire in an affordable package. But while the Minié rifle was definitely one of the most advanced mass-produced firearms of its time, it would soon get overtaken by breech-loading rifles. Breech-loading guns could fire faster than any muzzle-loader, but they had their own set of problems. The worst was hot gases escaping from the breech during powder ignition, which lowered projectile velocity and could potentially burn the shooter's face if they were firing from the shoulder. The Norwegian army was one of the first European powers to adopt a breech-loading rifle as standard infantry weapon with the M1842 Cammulator, which used a unique crank-operated mechanism to seal the breech tight before firing. But even though the Cammulator was an excellent design, that thick, heavy breech mechanism was headed for obsolescence as metallurgy advanced in leaps and bounds throughout the long 19th century. Chapter 2: The Bolt-Action Era and the Machine Gun Age. While the great powers of Europe were busy with the Crimean War, the Kingdom of Prussia was looking to leapfrog ahead of its competitors by adopting the breech-loading Sonderdelger, or needle-ignition rifle, otherwise known as the Dreyse needle gun. Initially prototyped by Johann Nicolaus von Dreyse in the 1820s, the needle gun used an innovative new bolt-action mechanism that made it easy to load and fire in any position, instead of using a hammer or serpentine. Pulling the trigger caused a sharp metal needle to punch through the paper cartridge in the breech and detonate the percussion cap, hence the term needle gun. The bolt-action mechanism was lightweight, and the entire weapon could be easily field-stripped in the heat of battle, allowing for rapid replacement of damaged parts. This was important because Dreyse's design was at the bleeding edge of firearms tech. The needle was the most commonly replaced part, and imperfect gas seal lowered overall performance. Nonetheless, the benefits vastly outweighed its early problems, and after the Crimean War, most European nations would adapt the design and bolt-action features for their own standard infantry rifles. Now, let me take a quick second to discuss some important considerations commanders had back then about new firearms. By far the biggest was logistics. Infantry rifles needed to be cheap and easy to mass-produce. Before steel casing was invented in the mid-1800s, firearms were hand-tooled, relying on skilled gunsmiths to get consistent results. But even after mass production came along, military thinkers preferred to stick with centuries-old tactics. Conscript armies marched in mass formations, so the need for individual firepower was downplayed. More complex guns meant more training, making soldiers harder to replace. For many nations, it was simply easier to rely on quantity over quality. A great example of how quickly firearms evolved during the latter half of the long 19th century is found in the American Civil War and the Spencer repeating rifle used by some Union cavalry regiments. The Spencer repeating rifle was among the first ever magazine-fed rifles adopted into military service, and one of the first to use both a lever-action mechanism and a metallic cartridge. Spencer rifles had a tubular opening bore to a buttstock, where up to 7 cartridges could be inserted nose first. Lowering the lever allowed a spring to push a cartridge into the receiver, while raising a chamber to round, leaving only the hammer needing to be cocked before the rifle was ready to fire. This meant a Spencer repeater could empty its 7-round magazine in less than 15 seconds. To Confederate troops still using mostly muzzle-loaders like the Enfield Pattern 1853, encounters with Union cavalry armed with Spencer repeaters were absolutely devastating, with half a dozen mounted troops easily able to dismount and match the firepower of a whole platoon armed with caplocks. Another secret to the Spencer repeater success was its use of a metal cartridge, the first prototypes of which had been created way back in 1808 by Swiss gunsmith Jean Samuel Pauli. Before his work, paper cartridges containing bullet, powder charge, and primer had been common, but metal cartridges protected their contents from the elements way better and created a natural seal against gas leakage. One of the first commercially successful firearms using metal cartridges was the Model I revolver released by the Smith & Wesson Company in 1857, which used .22 rimfire ammunition, where the primer was contained in a small metal lip around the rear wall of the casing. The Spencer repeater also used a rimfire cartridge, but even by the 1860s, gunsmiths were transitioning to centerfire round with the primer located in a recessed cup at the base of the round. This enabled much higher powder loads, allowing metallic cartridges to be scaled up to rifle calibers. Though weapons like the Spencer repeater made a dramatic entry onto the world stage, they would soon be overshadowed by something bigger still, something that would change the face of warfare forever. That something was a Gatling gun, designed by Richard Jordan Gatling and patented in 1861. With an innovative hand-crank mechanism that rotated 6 barrels around a central shaft and loaded them individually from a steel cylinder filled with paper cartridges, the Gatling gun was capable of firing not just dozens but hundreds of rounds per minute. Contemporary designs like the French Mitrailleuse and Union Ager gun also existed but came with severe drawbacks. The Mitrailleuse fired a single shot from each of its dozen barrels before needing to be reloaded, making for tremendous volleys but poor sustained firepower. The Ager, meanwhile, used a complex revolver mechanism that was exhausting to operate, and its single barrel rapidly overheated. The Gatling gun was a design that bridged the gap between the repeating firearm and the artillery piece, being a crew-served weapon designated to engage enemy forces with continuous direct fire using rifle-caliber ammunition. Astonishingly, though, the first Gatling guns were regarded as almost useless by both Union and Confederate generals, given their tendency to jam and the vast clouds of powder smoke they generated. Richard Gatling was forced to take his design overseas, resulting in the Gatling gun quickly becoming the weapon of choice for European militaries looking for more concentrated firepower against large armies of native troops in Africa and other colonial territories. In 1870, the Franco-Prussian War pitted German troops armed with Drey's needle guns against French infantry armed with Chassepot rifles. Though Prussian artillery and tactics would quickly rout the French army, the newer Chassepot proved superior to the Dreys, featuring a superior gas seal and faster projectiles that caused enormous wounds at much longer ranges. Realizing they were at a disadvantage, the Germans urgently began seeking a replacement rifle. After the war ended, the Mauser Company stepped up to the challenge with the Mauser Model 1871, a bolt-action design that proved far more robust than the delicate needle gun. By now, the age of single-shot rifles was quickly coming to an end, and in 1884, Mauser's design was updated to become one of the first standard-issue infantry long arms with a magazine similar to that of the Spencer repeater. Soon after, British-Canadian gunsmith James Paris Lee perfected an integral box magazine fed by stripper clips. But single-shot guns weren't obsolete yet, and designs like the Martini-Henry rifle proved the perfect weapon for British troops operating all across their vast empire. In such remote territories, ammunition supply was a huge factor, and as ammunition grew more complicated, so too did the cost of shipping it out to the troops. This was also a drawback for guns like the Chassepot, whose rounds cost twice as much and were twice as hard to make as the simpler Drey's cartridges. Though many officers saw the potential of rapid-firing guns, they also recognized that their introduction would triple any military budget overnight and create new supply chain issues that would take decades to fully address. The 1880s would see 2 more giant leaps forward in firearms technology. The first came thanks to the work of British inventor Sir Frederick Abel, who patented a smokeless repellent known as cordite in 1889. Cordite was a mixture of newly created chemicals, such as nitrocellulose and nitroglycerin, that burned far more cleanly and efficiently than black powder. The patenting of cordite and other similar formulas solved the issues of barrel fouling and excess smoke production, meaning that weapons like the Gatling gun saw the largest benefits. While the idea of using the recoil of a discharging firearm to cycle the action and chamber a new round had existed since the 1870s, it was the work of British-American Hiram Stevens Maxim that created the world's first automatic weapon in 1884, the Maxim gun. With a single barrel encased in a water-filled jacket, the Maxim gun was relatively lightweight at around 60 pounds and could be operated by one man using a collapsible tripod, making it infinitely more portable than a carriage-mounted 170-pound Gatling gun. Much like its older counterpart, the Maxim gun was first employed by the colonial powers during the scramble for Africa. But with the advent of smokeless powder, the frequent jamming issues that plagued both rotary and automatic weapons finally became a thing of the past, and the Maxim gun was soon being bought by many European powers, ushering in the age of the machine gun. While previous inventions like the repeating rifle had shown the obsolescence of Napoleonic-era tactics, it was a machine gun that would finally destroy all vestiges of the military status quo that had dominated Europe since the invention of the musket. Oyudiaro, As the long 19th century drew to a close, the arms race between nations only intensified. In the span of about 70 years, militaries had gone from using muzzle-loaded smoothbore muskets with an effective range of less than 50 meters to magazine-fed rifles that could land a bullseye over 600 meters away, and machine guns were quickly coming to dominate the battlefield. Unfortunately, history has taught us that doctrine marches one step behind technology. During the Great War, generals convinced they could replicate the lightning advances of the Franco-Prussian War through thousands of men equipped with bolt-action rifles against entrenched machine gun positions, resulting in unspeakable losses. But even this deadlock didn't last forever, as even more advanced weapons like tanks and improved artillery would eventually break these defensive lines and render them obsolete as well. That's the wild evolution of firearms in the 1800s, from simple muskets to devastating machine guns that changed warfare forever. Catch you next time.